To kind of come back and wrap this up or summarize some of the things that we've talked about throughout this unit on soil-water relationships, a good way to end this unit is to look at the different methods we have developed for measuring soil-water content. The very first method we talked about was the gravimetric method. The gravimetric method is measuring the actual content of water in the soil. It gives us a useful range in terms of kilopascals. Remember, we'd have to move the decimal 2 positions to the left if we're talking about bars or atmospheres of soil moisture tension, or soil moisture content in this case. Gravimetric is used primarily in the lab. Remember, however, though, that it is pretty much the standard that we use for calibrating the other direct soil moisture monitoring techniques that are listed below this one on this particular graphic or chart. We did not talk specifically about resistance blocks. Resistance blocks are a method of measuring soil moisture content in the field. Their range is given here in terms of values. Can be automated, not sensitive, near optimum plant water contents. Resistance blocks, also oftentimes referred to as gypsum blocks, are utilized somewhat in the field, but in more recent years have oftentimes been replaced by newer techniques of soil moisture monitoring. The third method mentioned here, neutron scattering, probably more familiar to yourself as the neutron probe. Does have some advantages and disadvantages. It does measure the content of soil water. It has a very broad range of representation here. It is a field method. You do have to understand that it is neutron reflectation type of technique, so that what's happening here is you're actually emitting a source of radiation. And people that utilize these do have to receive some training and obtain a permit in order to utilize this equipment, and it's also quite expensive. You also have to establish stations in the field where you're going to be taking these readings, and at those stations you have an access tube. In other words, a tube in which you insert this neutron probe that is actually sending out radiation, and based upon these neutrons being reflected back by water molecules, we are receiving a reading of the amount of moisture that is being held in that particular soil. These neutron probe technique does indeed have to be calibrated back to our gravimetric water content, so that when we have a certain neutron probe reading, we know the actual content of water being held in that soil. But that's something that would normally be done at the time this technique of soil moisture monitoring was being implemented. I'm not going to talk too much about TDR, or time domain reflectometry. It is a relatively new technique. It has application for both field and lab. It's very expensive instrumentation, and it's something that is not that commonplace in the market at this point in time. A technique that has been used for a good many years and is continuing to be utilized is called a tensiometer. Now you can see this word tensiometer is measuring soil moisture tension, and we've developed a meter or mechanism by which we can do this. It is measuring not water content but soil water potential. So it's taking a measurement of the pull that the soil has for the water that remains in that soil. It has a range of about 0 to minus 85. That is perfectly adequate, although it appears small. It is perfectly adequate for field soil moisture monitoring. It is used in the field. It is not a laboratory technique. The disadvantage of tensiometers is that they need to be placed in the soil and left there for a period of time, and then read periodically to get to determine soil moisture content. And as it indicates here, they do need periodic servicing. They are relatively inexpensive compared to neutron probes or TDR type of equipment. They are quite commonly being utilized in the irrigation industry as a method of soil moisture monitoring by determining the tension with which the water is being held by the soil. Disadvantage, even though they're relatively inexpensive, the disadvantage is that you have to have a number of these stationed throughout the area that you want to monitor soil moisture on, because the portability of these is really not that great in that they need a period of time in the soil in order to function. Thermocouple psychrometer is also another technique. It's more of a laboratory technique, as is the pressure membrane apparatus, more of a research laboratory technique. So we're really looking at tensiometers, newer technology going to TDR, neutron probes being utilized quite a bit, still some use of resistance blocks, and all of these techniques are most often calibrated or tied back to gravimetric water content, which of course is done by constant soil sampling. If we got a certain reading on a resistance block and we wanted to know how much water was being held, we would have to refer back to our calibration charts that we'd done with our gravimetric water determination and how those responded or corresponded to specific resistance block, neutron probe readings, and or tensiometer readings. Those can all be calibrated with the gravimetric method. So what I've asked you to do in terms of calculations here, we're utilizing the gravimetric technique to calibrate this other more constant monitoring type of equipment that is oftentimes being used in the irrigation industry today.